I'm Anil Kumar. Welcome to my series on linear systems. We'll now discuss Cramer's rule and understand how to solve linear systems using Cramer's rule. To understand the basic concept, I've taken a very general equation which is a1x plus b1y equals to c1, a2x plus b2y equals to c2. So let's number these equations as our equation number 1 and 2. So let's say this is our equation number 1 and this is our equation number 2. Now to solve this, what will you do? Well, we have to eliminate one of the variables. So let's decide to eliminate y. So in that case, what should I do? I could multiply equation number 1 with b2, right? So I'll do times b2, and then I will take away from that equation number 2 times b1, correct? So that is what I'm going to do. So if I multiply the first equation by b2, I get a1 b2x plus b1 b2 y equals to c1 b2, right? The second one I'm multiplying with b1, so I get a2 b1 x plus b1 b2 y equals to c2 b1, correct? So when I do that, I get two new equations. So we are calling these as our equations number 3 and 4. Now the next step, I want to take away from equation 3 equation 4. So if I take away, I'm going to cancel one of these terms, which is right there, right? So this can be cancelled, and so I could write what? So this cancels, correct? So what you get here is a1 b2x minus a2 b1x equals to c1 b2 minus c2 b1. You can take x common, right? So then what do you get? You get a1 b2 minus a2 b1 equals to c1 b2 minus c2 b1. And from here you can find the value of x as a ratio of this, which is c1 b2 minus c2 b1 over a1 b2 minus a2 b1, correct? So we find that it is a very interesting ratio, which is kind of written like this, right? Now to do or to find the value of y, what you could do is you could do very similar steps. Let's do it here. So if I have to really isolate y, then I have to multiply these two equations by what? So let's try to figure this out. So equation 1 will now be multiplied by, because we want to eliminate x, so I'm going to multiply this by a2 and then take away from it equation number 2, which will be multiplied by a1, correct? So let's do it in a different ink. We get a1 a2 x plus b1 a2 y equals to c1 a2, right? And the second equation becomes a1 a2x plus b2 a1, right? Y equals to c2 a1. And when you isolate this in a similar fashion, we have to just take away, right? So exactly same steps you're going to do. And what you get here. So straight away, I'll write down the answer. You know, these terms will cancel. Okay, so let me cancel these terms. The same, we're left with y's on this side. So I could write here that y is equal to difference of these two, which is c1a2 minus c2a1 divided by these two differences, which are b1a2 minus b2a1. Does make sense to you? So what you see here is kind of a pattern, correct? So that is made advantage of in Cramer's rule. And now we'll introduce you the tools which can help us to solve linear systems with n variables, right? So that's the beauty of this Cramer's rule. So what we are going to learn now is a very interesting and a powerful tool. We have learned so far that a matrix can represent n equations. When we say n equations, we are talking about n variables. Clear? When we are talking about n equations with n variables, we are also talking about square matrix. So these are key to understand. So we are working with the square matrix. Okay. Now the idea here is to introduce to you determinants which give you value of a matrix, right? So what we introduce here is determinants. That determines value. Of matrix. So when we say of matrix, we are only concerned with square matrix, right? But we could have of n by n dimensions, right? So we're talking about n by n. Is it okay? So that is what we are looking into. Now, to get back to this topic, let's again talk about writing this equation in the matrix form now. Okay, let me partition this page as we can do in matrix also, right? So, okay, let's see. So this particular equation which we had here, a1x plus b1y equals to c1 and a2x plus b2y c2. Basically, if I look into the left side of this equation, we could write a coefficient matrix which is a1 b1 a2 b2, right? This is the coefficient matrix. So what we are going to do is write this coefficient matrix into the form of a determinant, which will be for us a1 b1 a2 b2, right? So that becomes a determinant, right? So from matrix we move on to determinant, and now the value. So what is the value of this? Very easy to figure out. What we do is we do kind of cross multiplication. So we are looking into these terms in the denominator a1 b2 minus a2 b1. So this is how you get them. So if I multiply in this fashion, what do I get? I get a1 b2 and then I need negative. So when you multiply in this way from the one which is in the second row, we get minus a2 b1. Do you see that part? So that is the representation from a matrix to a determinant to a value, right? So finally we get a value to work with. Solving equation basically means you have to work with some numbers, right? So that matrix has been converted into a number. And now look what? X is what for you now? So let me write down X in terms of our new defined determinant. So it gives you a ratio of two determinants. Denominator I have shown very clearly, which is a1 b1 a2 b2, correct? How about the numerator, which is c1 b2? So well, we can fabricate this, right? So c1 b2 means c1 b2, okay. c2 b1 means c2 b1. Does it make sense to you? So it basically becomes from the equation a direct value, which is our solution, right? So what we have done here, the denominator is the coefficient matrix and the numerator is again the same coefficient matrix, but when you're trying to find the value of x, the coefficient of x has been replaced by c's. You get the idea. Well, how do you find y? Now to find the value of y, we have almost the same thing there. Denominator is exactly the same, right? Okay, so now what? So what I wrote was, I should have written, okay, so that's it. So So it's kind of a A1 Yeah, I could have reversed this order. I could have written this I could have done equation 2 minus equation 1. So I could actually also write this as, let me rewrite this. I want to write A1, B2 first, right? Just to maintain this particular order. So look here, I'm making both sides negative. Does it make sense to you, right? So what I'm doing here is just flipping this over so that I get A1 terms first, right? So I'm reordering this. So I'm writing this as A1B2 minus A2B1. So I just switched the order for both numerator and denominator, right? So I'm writing this as A1C2 minus A2C1. Does it make sense to you? So I just put negative so that, we could write exactly the same thing here. Okay. So we have the same denominator, right? A1B2 minus A2B1. So that makes it A1B2 minus A2B1, clear? And in the numerator, what you have is A1C2, right? So basically, what has actually become here as A1, instead of C is on the left side, replacing the value of X coefficients, when you want to find the value of Y, they replace B's. You understand? So that's what it is. We have A1, A2 here and C1, C2 there. Easy to remember. Do you see that part? Correct? So I hope that makes sense. So what you see here is that we can easily find solution of a linear system using Cramer's rule. Now this was in the name of Cramer's, so it's Cramer's rule, well known. Okay. So you have some denominator here. Of course, the denominator cannot be 0. So the rule here is applied when A1, B1, A2, B2 is not equal to 0. Correct? That is very important. Now we'll also understand what happens when this is 0. Whenever it is 0, then you don't really have a consistent system, right? So when it is 0, then the condition could be these lines representing lines in this particular case. We're talking about these two lines. That means that they are parallel or they are coincident. So parallel means no solution, coincident means infinite solutions, right? So that is also a very important conclusion from here, that if the denominator is 0, you cannot really find the values of X and Y. System is not consistent, correct? So we come to a rule that system is consistent. System if and only if this determinant, which is A1, B1, A2, B2, is not equal to 0. Do you see that? So that is another conclusion from all this. But anyway, what I've introduced you here in very short may take quite some time to understand and apply. So what we have learned here is that for a linear system of two equations, two variables X and Y, we can directly find the value of X and Y using ratio of these determinants, right? So these are basically coefficients of your equations. Numerator, if you're wanting to find the value of X, then replace the coefficient of X by the constant C1, C2. If you want to find the value of Y, replace the coefficients of Y by C1, C2. Denominator is the coefficient matrix on the left side. Does make sense to you? Okay, so we'll take two examples, one with 2 by 2, that means equations with two variables, and one with equation with three variables, and then you'll see huge advantage of using Cramer's rule for solving linear systems, and it can be extended to n equations. That's the beauty. So let's take up an example and figure it out. Thank you. Here is our first example. We have a linear system with two equations, two unknowns, right? So using the Cramer's rule, we know our solution is that the value of X should be equal to the ratio of two determinants. One will be the coefficients of x and y, which is 2 minus 3, 3 and 2. Since we are trying to find the value of x, we'll replace the coefficients of x with the c values, which are minus 3 and 28, and retain the values for the y coefficients, and that gives you the value of x. To find the value of y, what are we going to do? Exactly similar thing. Denominator will be exactly same, which is 2 minus 3, 3, 2. And the numerator will be replacing the coefficients of y this time. So x coefficients remain same, the y coefficients becomes minus 3 and 28. And we get its value. Correct? So it is always a good idea to begin with the denominator part and check if this denominator, which is 2 minus 3, 3 and 2, is 0 or not, right? So the value will be, you have to multiply 2 times 2, right? So you multiply 2 times 2 and take away 3 times minus 3. So that gives you 4, and that becomes plus 9, and that gives you the value as 13. So 13 is not equal to 0, so the rule works, right? So which is not equal to 0, so that is perfectly fine with us. Correct? So now let's calculate the values here. So the x value will be minus 3 times 2, so let me write down minus 6 here. Minus, so that's a bigger number. Minus and minus makes it positive. 3 times 8 is 24, 2. 3 times 2 is 6, 6 and 2 is 8. And we have to divide by, so divide by, we have already worked out this value as 13. Okay, that's nice. So that's what we get. And now we will take away 6 from 84. So we get 78, right? 78 over 13. So what is 78 over 13 equals to? Well, that turns out to be 6, right? So we get the x value as 6. Perfect. See how simple, straightforward it is? Any problems? No. Now let's do this. Y values, 2 times 28. So 8 times 2 is 16, 6, 1, 56. Okay. Take away this value. It becomes positive since 3 is negative, 9. And then we have to divide by the number 13, which we found for the denominator. Good. Now when you add them up, 56 plus 9 gives you what? It gives you, if it was 6, okay, 6 and 9 is 15, 5, and 165 divided by 13, that gives you a value of 5. Perfect. So we get a solution, and the solution is clearly that x is 6 and y is 5, right? So our answer here is x equals to 6 and y equals to 5. Isn't that amazing? So I hope you understand and appreciate what we have done. In no time we could get the solution of this system. Now you'll definitely like to check it, correct? So let's check this answer. Right, it's too good to be true. So let's do this. So if I write 2 and the value of x as 6, and then 3 with a negative sign, the value of y as 5, 2 times 6 is 12, minus 15. I do get minus 3. That is correct. The other one is 3 times 6 plus 2 times 5, which is again 18 plus 10. It is indeed equals to 28. That is also correct. Do you see the beauty? So that is how we could actually apply Cramer's rule and easily solve any system. And of course, if the denominator is 0, you also know that it is either a set which will give infinite solutions or no solutions. So either way it works. So at this stage, we can take a break. I'll go for a short walk, and then we'll take up an example with 3 equations, and then we'll relate it with vectors solving intersection of planes. That is the whole idea. I hope that makes sense. Correct? I hope you'll love it. Thank you, and wait for some time for the intersection of planes, right? Thank you.